How did anyone manage to paint the Golden Gate Bridge, hundreds of feet above open water, when wind gusts reached 60 miles per hour and safety harnesses were barely a concept? Most people think painting the bridge was just routine upkeep. In reality, it was a daily battle against freezing fog, salt air, and dizzying heights. An engineered fight for survival, not maintenance. The paint itself was loaded with lead, chosen less for safety than for clinging to the steel through brutal weather. Scores of local workers, desperate for jobs during the Great Depression, faced risks and hardships that would be unthinkable today. If the bridge's legendary orange still shines, it is because their skills and improvisation lasted where rules and gear did not. What drove ordinary people to take on a job this dangerous, and how did they actually pull it off? Ask anyone how the Golden Gate Bridge stays so bright and iconic, and most will picture a team of painters just brushing on a fresh coat every few years, like it is no more complicated than repainting a fence. But the reality is far from routine. Painting this bridge has always been a massive, orchestrated operation, planned down to the gallon and the hour, with every brushstroke shaped by the bay's wildest moods. From the start, the Bridge District treated maintenance as a matter of engineered survival. Archival records reveal formal maintenance schedules and procurement memos that read more like military logistics than janitorial checklists. The original order alone called for over 100,000 gallons of lead-based primer and custom mixed international orange supplied by the International Paint Company. Each shipment was tracked, every batch documented, all to defend the steel against the relentless salt air and fog that roll in from the Pacific. This was not just about keeping the bridge looking good. The paint system itself, 2/3 lead by weight, was chosen for its ability to hold fast in the face of constant moisture and salt, forming a shield against rust that could eat through steel in months if left unchecked. The choice of international orange was not just for show either. Consulting architect Irving Morrow pushed for a color that would cut through the fog, making the bridge visible to ships and planes even on the grayest days. But none of this was simple. The sheer size of the bridge, towers rising 746 feet, cables stretching more than 4,000 feet across open water, meant that every maintenance plan had to account for wind, weather, and the limits of human endurance. Painting was not just a scheduled task, it was a campaign, requiring careful coordination, specialized equipment, and a workforce trained to adapt on the fly. Every day brought new challenges, gusts that could whip a man sideways, fog that delayed drying times, salt that corroded even freshly painted steel. What kept the bridge standing was not just the paint, but the human systems behind it, the schedules, the procurement, the relentless drive to outsmart the elements. The next time you see that orange span cutting through the mist, it is worth remembering. The color is the product of strategy, sweat, and survival, not just routine upkeep. Wind is the first and fiercest adversary on the Golden Gate. Gusts roar through the strait at speeds that can reach 60, even 70 miles per hour, enough to rattle steel and send a man gripping for his life. The bridge's towers rise 746 feet above the water, higher than most city skyscrapers, exposed to every shift in the weather. Out here, there is no shelter from the elements. The wind does not just howl, it pushes, it lifts, it twists. Painters learned early that a sudden gust could whip a hanging platform sideways or tear a brush from a gloved hand. Even standing still, the sensation of swaying hundreds of feet above the bay could turn strong legs to jelly. Fog pours in from the Pacific, thick and icy, soaking clothes and turning every surface slick. It clings to the steel and slows the drying of paint, sometimes halting work for hours. When the fog lifts, the salt it carries lingers behind, eating into bare metal faster than the eye can see. Every exposed bolt and cable is under constant attack. The salt air does not just corrode, it demands a thicker, tougher barrier, which is why the bridge's original coating was loaded with lead, chosen for its ability to block moisture and resist the steady assault of the sea. At this height, the environment is never still. Even on clear days, the wind can shift in seconds, and the cold bites through wool and leather. Workers describe the sensation as standing inside a moving storm, with the ground so far below that the horizon itself seems to tilt. The Strait's microclimate, its sudden gales, freezing fog, and salt spray, dictated every decision about what paint to use and how to apply it. The bridge is not just a span of steel, but a battleground where every brushstroke is a fight against the elements. The need to defend the structure from this relentless environment shaped the choice of paint, the thickness of each layer, and the design of the rigging systems that kept crews in place. Here, nature calls the shots, and survival depends on learning its moods. Red lead primer was the backbone of the Golden Gate Bridge's first line of defense. Every steel beam and cable arrived at the site already coated in a thick, rust-red paste, about 2/3 of it pure lead by weight. This was not just a matter of tradition or habit. In the 1930s, lead offered unmatched protection against rust, especially in the salty, wet air that batters the bridge year-round. The chemistry was simple but effective. Lead oxide formed a dense barrier, locking out moisture and keeping corrosion at bay for years, even as the fog rolled in and the winds howled. But working with it came at a cost. The paint was heavy, toxic, and stubborn. It clung to brushes, stained gloves, and filled the air with dust that stuck to skin and clothing. Painters had to mix it on site in steel drums, adding linseed oil and pigment by hand, with little more than cotton masks to guard against fumes. On top of this base went the color that would define the bridge for generations: International Orange. The choice was not arbitrary. Architect Irving Morrow rejected the Navy's proposed black and yellow stripes, insisting instead on a color that would blaze through San Francisco's legendary fog. The color was not just bright, it was visible to ships and planes, a beacon against gray water and sky. The pigment, custom mixed by the International Paint Company, was designed to hold its color under harsh sunlight and constant storms. But it came with its own headaches. The paint had to be thick enough to withstand the weather, yet thin enough to spread evenly over rough steel. In cold or damp conditions, it could run, sag, or refuse to dry, forcing crews to wait out the fog or warm the surface with portable lanterns. Applying this system at scale was a technical challenge in itself. Every coat had to be uniform, every seam sealed, or rust would creep in beneath the surface. The size of the bridge meant that paint was always exposed somewhere, stripped by wind, softened by fog, or scoured by salt. Crews could not just slap on a new layer and walk away. Each section demanded careful prep, scraping down to bare metal, priming, then layering on the orange, all while suspended hundreds of feet above the bay. The paint system, chosen for its toughness and visibility, set the rules for everything that followed: how workers moved, what tools they used, and how they battled the elements to keep the bridge alive. Steel alone could not put a painter in the right spot on the Golden Gate Bridge. The real feat was building the moving platforms, catwalks, and anchoring systems that let crews reach every inch of cable and tower, even as wind screamed through the strait. Early engineering drawings show a tangled web of steel trusses and suspension lines, each piece calculated to hold men and equipment hundreds of feet above the water. The backbone of this system was a series of suspended catwalks built from steel latticework and anchored directly to the main cables. These catwalks spanned the width of the roadway, stretching from tower to tower, and served as the main arteries for foot traffic and paint supplies. Adjustable hoist lines connected the catwalks to the big cables overhead, so the entire platform could be raised or lowered as needed. For work on the towers themselves, crews relied on gondolas, open swinging platforms winched up and down the sheer faces, offering just enough room for a few men and their gear. But wind made everything more complicated. Standard rigging would sway and shudder in a stiff breeze, sometimes swinging several feet side to side. As wind speeds approached 50 or 60 miles per hour, the threat of a platform breaking loose or tipping over became real. To counter this, engineers devised a system of temporary ballast anchors, massive concrete blocks, each weighing about 4 tons, hoisted up to the tops of the towers and lashed in place. These anchors increased the mass of the rigging, calming the wildest swings and shifting the natural frequency of the whole structure so it could better resist sudden gusts. Guy wire anchors, thick steel cables bolted into the tower's ribs, offered another layer of security. By spreading the load and holding the rigging steady, they kept the catwalks and gondolas from drifting too far in the wind. Adjustable tensioners were built into the suspension cables, allowing crews to tighten or loosen the whole system depending on the day's forecast. When a storm rolled in, workers could crank down the tension, reducing the lateral movement of the platforms to less than 2 feet, even in gusts that might otherwise make painting impossible. Safety nets hung 15 feet below the catwalks, ready to catch any man or tool that slipped. These nets were more than just a last resort. They were a constant reminder of the stakes. Engineering schematics from the Bridge District archives outline the geometry of the whole setup. Primary suspension lines to the main cables, secondary lines to the ballast anchors, and placement of winches and signaling bells. Period photographs capture the precarious balance. Workers perched on narrow walkways, cables humming in the wind, the whole platform shifting with every gust. This network of rigging and hardware did more than just hold men in place. It made the impossible possible, turning a 746-foot-high, wind-battered span into a workspace where painters could do their job. Every clamp, block, and tensioner was a response to the relentless environment of the Golden Gate. Proof that survival here depended as much on mechanical ingenuity as on courage. Names like O'Leary, Delgado, Rosenberg, and Sullivan don't appear in textbooks, but their fingerprints are all over the Golden Gate Bridge. The early painting crews were a patchwork of backgrounds and stories, including Irish and Italian immigrants, Mexican and Filipino laborers, a handful of women, and Americans drawn from shipyards and city neighborhoods. They came for steady work in the depths of the Great Depression, when a day's pay on the bridge meant a roof and a meal that week. Payroll ledgers from July 1936 show the scale of the operation. Foremen like Jack O'Leary and Sam Delgado earned $7.50 a day, a sum that outpaced most jobs in the city. Master painters such as Eli Rosenberg, who brought marine coating expertise from New York shipyards, could make $9 a day, a premium for those trusted to handle toxic lead paints and to battle the bay's worst moods. O'Leary was famous for his hands-on approach, climbing ahead of his crew to test the catwalks before anyone else set foot on them. Delgado, a meticulous record keeper, logged daily wind speeds, paint batches, and crew assignments in a battered notebook. Rosenberg introduced a rolling brush technique that minimized overspray, a small adjustment that kept more paint on the steel and less in the wind. Then there was Martha Marty Sullivan, a rarity for the time, who worked as a color mixing specialist. Her diary entries describe the psychological toll of working 600 feet above the water, wind howling so loud she could barely hear the foreman's whistle, the steel trembling underfoot. The crews started each day at the tower base, checking the anemometer and waiting for the foreman's signal. If the wind was under 45 miles per hour, they climbed the steel ladders to the catwalks with only rope harnesses, no modern fall arrest gear, and no hard hats at first. Paint was mixed in steel drums, with linseed oil and red lead pigment stirred by hand. Sullivan's job was to get the color just right, batch after batch, even as the fog rolled in and the temperature dropped. The introduction of low-pressure airless sprayers in 1936 was a leap forward, but much of the work still relied on brushes and rollers, with every stroke threatened by the next gust of wind. Lunches were short and often eaten on the catwalks, boots dangling above the bay. The camaraderie was as vital as the equipment. Crews swapped jokes and songs to blunt the fear, sharing stories of close calls and small victories. The work was relentless and exhausting, but the pay was good enough to draw lines of men hoping for an opening. For many, the bridge was more than a job. It was a test of nerve, skill, and endurance. Every brushstroke was a wager against the wind, every finished section a quiet act of defiance against the elements. The bridge's color endures not just because of chemistry and engineering, but because of the people who risked everything to keep it alive. Wind. On the Golden Gate Bridge is not just a background detail. It is the force that turns every brushstroke into a gamble. When gusts hit 60 miles per hour, the bridge's steel towers begin to hum and sway, setting off a chain reaction that travels down every cable and platform. The anemometer mounted on the tower does not just measure wind for records, it is a warning system. A reading above 45 miles per hour means crews have to stop, but even below that, the air is rarely still. At higher speeds, the suspended catwalks and gondolas become pendulums, swinging in broad, stomach-churning arcs. Workers describe the sensation as standing on a moving floor, with the entire rig shifting beneath their boots, sometimes drifting several feet sideways in a single gust. Paint itself becomes unpredictable in this environment. A brush loaded with lead primer can send droplets flying 20 feet off target, the wind snatching pigment before it touches steel. Overspray is not just a nuisance, it is wasted material and lost protection for the bridge. The physics are unyielding. As wind speed rises, the chance of paint landing where it is meant to drop sharply. Painters had to develop a sixth sense for the rhythm of the gusts, waiting for brief lulls to lay down a coat, then bracing as the next blast threatened to peel it away before it could dry. Oscillation is more than a word in the engineering logs. It is a daily reality. The catwalks, engineered to flex but not fail, can swing up to 2 feet side to side during a strong blow. If the natural sway of the platform matched the frequency of the wind, the movement could amplify, making steady painting impossible. Material behavior changed hour by hour. Primer thickened in the cold, topcoat ran in the damp, and any exposed steel risked flash rusting if the paint did not stick fast. The battle was constant against the wind, the elements, and the stubborn physics that made painting the bridge a technical and physical trial. Every solution, from weighted anchors to new brush techniques, was born out of this relentless fight with the air itself. Painters on the Golden Gate Bridge became experts at reading the wind and working around it, not because they wanted to, but because they had no other choice. On mornings when gusts threatened to tear the catwalks loose, foremen like Jack O'Leary would gather the crew at the base, eyes on the anemometer. If the wind dropped below 45 miles per hour, even for just 15 minutes, the signal bell would ring, and the team would scramble up, brushes and buckets in hand, ready to make the most of the brief calm. These windows were precious. Crews learned to work in bursts, painting quickly during lulls, then hunkering down as the next round of gusts swept through. Improvisation became second nature. When wind picked up mid-stroke, workers would rig canvas tarps as makeshift windbreaks, lashing them to the steel with rope and wire. These barriers never held back the full force, but they could slow a gust just long enough to finish a patch of primer. Paint buckets and tools were tied off with lengths of cord. After a near miss in November 1937, when a dislodged bucket struck a worker on the head, every tool had to be tethered by order of the foreman. The routine itself was shaped by the elements. Crews stuck to a strict policy. Every 90 minutes, everyone climbed down for a rest, a chance to shake out numb fingers and steady their nerves. The wind and cold wore down even the toughest men and women, so these breaks were not just for comfort, they were essential for survival. Oral histories from workers like Martha Sullivan recall how the crew would swap stories and advice during these pauses, sharing tricks for keeping paint on the steel and not in the bay. No matter how clever the fix, the wind always found a way to remind them who was in charge. Even the best-timed brushstroke could be undone by a sudden squall. The painter's ingenuity kept the bridge bright, but it could not erase the risks. Accidents still happened, and every patch of orange stood as proof of both human creativity and the limits of what even the best crews could control. Long before federal safety rules or modern equipment, the only thing protecting a painter on the Golden Gate Bridge was habit, experience, and whatever the union could win at the bargaining table. There were no hard hats at first, no harnesses rated for a fall from 700 feet, and no government inspectors making surprise visits. The International Brotherhood of Iron Workers kept a close eye on conditions, filling their 1936 grievance docket with complaints about lead fumes and vertigo-inducing drops. Their demands were simple: better masks and some way to clear the air after each batch of paint. The district responded with cotton gauze face coverings, thin, scratchy, and barely effective against clouds of red lead dust. Alongside these makeshift respirators, a new rule was posted. After every round of paint mixing, the crew would step away for 10 minutes, letting the wind sweep the fumes off the catwalks before anyone returned to work. These protocols were hardly foolproof. Cotton masks offered little real protection, and the 10-minute air-clear pauses were more a gesture than a guarantee. Still, they represented a rare concession in an era when most safety was left to personal judgment and peer pressure. The union's push for basic protections did not stop at masks. After a near miss in 1936, when a snapped bracket sent a worker tumbling into the safety net, crews pressed for a second tier of netting, another layer between themselves and the bay. The district agreed, installing extra netting beneath the main work platforms. Even with these measures in place, the limits of the era's safety culture were clear. Workers relied on each other, on their own routines, and on the hope that the wind would hold steady long enough to finish a section without incident. Every day, the bridge demanded a wager, skill and caution against the unpredictable forces of nature, with only the thinnest margin for error. The bridge's survival depended not just on engineering, but on the quiet, uneasy partnership between labor, management, and the elements. The Golden Gate Bridge's safety log reads like a ledger of close calls, each entry a reminder that survival on the cables was never guaranteed. On the morning of March 12, 1936, a gust clocked at 58 miles per hour slammed into the North Tower. 4 crew members, led by Jack O'Leary, were midway across a swinging catwalk when a bracket holding the safety net snapped loose. The catwalk lurched past its designed limits, throwing men against the railings. Work stopped for 3 hours as engineers scrambled to retension the rigging and install extra brackets. No one fell that morning, but the silence in the logbook after the incident says as much as any dramatic headline. October 4, 1937, brought a different kind of scare. Sam Delgado and 2 painters were working from a gondola, suspended hundreds of feet above the water, when a painter lost his footing trying to secure a paint bucket. He dropped 30 feet into the net below, spraining his ankle but surviving. The entry notes the wind at 62 miles per hour and a decision to halt work for the rest of the day. The painter was sent to the hospital and the crew was pulled off the tower until the forecast cleared. The safety net did its job, but the margin for error was razor thin. The log from November 22, 1937, records a quieter but no less sobering moment. Eli Rosenberg and an apprentice were painting in a stiff wind 55 miles per hour when a paint bucket came loose, striking the apprentice on the head. He was diagnosed with a concussion. Work stopped immediately, and the next day's briefing introduced a new rule. Every tool and bucket had to be tethered to the rigging, no exceptions. The fix was simple, born from necessity, and quickly became standard practice. These entries do not dwell on heroics or drama. They are matter-of-fact records of brushes with disaster, written in the language of wind speeds, injuries, and repairs. Each incident forced a change, a stronger bracket, a new protocol, a pause for safety briefings. The cost of painting the bridge was measured not just in gallons of lead primer, but in moments when a net held, a rule changed, or a worker walked away with nothing worse than a bruise. The bridge's color endures because its crews learned, line by line, how to keep each other alive. Coordinating dozens of painters across a structure as vast as the Golden Gate Bridge, without radios and with winds howling at 60 miles per hour, demanded a language all its own. Every movement had to be choreographed, every decision relayed instantly from foreman to crew, or the risk of disaster multiplied. Bells, whistles, flags, and chalkboards became the nervous system of the operation, turning chaos into something close to order. At the start of each shift, the daily plan was scrawled on a chalkboard at the tower base. Crew assignments, target sections, and the expected weather windows were laid out in thick chalk, so every worker knew where to be and when. But once the men climbed into the wind, paper schedules meant nothing. Up in the steel, communication was stripped to its essentials. One long bell meant start painting, two short bells meant stop, usually because the wind had climbed past the safe limit. 3 sharp blasts from a brass whistle signaled it was time to move to the next section. These codes were drilled until they became instinct, a rhythm that cut through the roar of the strait. Hand signals filled in the gaps when sound was swallowed by the gale. Foremen, perched on the towers or catwalks, used colored flags, red for hold, yellow for go, to direct crews strung out over hundreds of feet. A raised arm or a wave could halt a line of painters mid-brushstroke, preventing a misstep when a platform started to sway or a gust threatened to snap a rope. In the worst weather, visibility shrank to a few yards, and the only thing a painter could trust was the flash of a flag or the echo of a bell. The foreman's role was part conductor, part sentinel. Men like Jack O'Leary and Sam Delgado kept constant watch, eyes flicking from anemometer to crew, ready to halt work at the first sign of trouble. Their judgment, honed by years of reading the wind and the bridge itself, often made the difference between a productive day and a near miss. The codes they enforced, simple, unmistakable, and universally understood, were the backbone of safety and efficiency. This choreography of signals, schedules, and silent understanding allowed the crews to move as one, painting the bridge in bursts between the bay's unpredictable moods. Each brushstroke depended not just on skill or courage, but on a system of communication that kept every worker tethered, if not by rope, then by trust and a shared language of survival. 3 forces kept the Golden Gate Bridge alive in the face of wind, salt, and time: engineered rigging, human endurance, and craft knowledge passed from one generation to the next. The bridge's survival depended as much on what was built for the painters as on the steel itself. Adjustable tension cables, ballast anchors, and dual-layer safety nets formed a moving platform that could be tuned to the day's conditions. When the wind threatened to turn a catwalk into a pendulum, ballast blocks, each weighing nearly 4 tons, were hoisted up and lashed in place, shifting the bridge's response to the elements. Tensioners let crews dial in just the right amount of give, keeping platforms steady enough for a brushstroke, even as gusts rattled the towers. These were not one-time fixes, but a living system, adjusted and improved with each season and every storm. But rigging alone did not keep the paint on the steel. The men and women who worked these heights built a culture of endurance, physical, mental, and communal. They learned to read the wind by the minute, to pace themselves through cold and fatigue, and to rely on each other's judgment when the fog rolled in. Mandatory rest breaks, strict schedules, and the unwritten rule that no one worked alone created a rhythm that made the impossible sustainable. The camaraderie on the catwalks, the shared rituals and jokes became as essential as any piece of equipment. The bridge demanded not just strength, but the ability to adapt, to improvise, and to persist through discomfort and fear. The third pillar was craft knowledge, hard-won, often unspoken, and always evolving. Techniques like the low-pressure spray, first introduced in the 1930s, set the standard for how paint could be applied in wind without wasting material. Rolling brush methods, on-the-spot mixing, and the careful timing of every coat became part of an internal manual handed down through crews. Even today, the philosophy behind those early techniques shapes modern maintenance. Robotic sprayers now use the same principles to coat the bridge's cables and towers, and the bell-code drills practiced in the 1930s still echo in the routines of present-day crews. The bridge's iconic color and resilience are not just the result of chemistry and steel, but of a system where engineering, endurance, and human craft work in concert, each one essential, each one a legacy of those who risked everything to keep the bridge standing. Every year, the Golden Gate Bridge still demands constant painting, now with safer gear and stricter rules, but always against the same relentless wind and salt. The bridge endures because each layer of color carries the imprint of human grit and risk. It's not just engineering, it's the story of people defying the elements so the landmark never fades. Next time you see that orange span, remember the hands that keep it alive. Share your thoughts below.